Good afternoon, everyone. It's my pleasure today to introduce Professor Sebastien Gambs from University of Quebec, Montreal. Sebastien is a PI on the Responsible AI project, and we're very excited to see his talk today on ethics washing and machine learning. Professor Gambs has held a Canada Research Chair in Privacy and Ethical Analysis of Massive Data since December 2017 and has been a professor in the Department of Computer Science at UQAM since January 2016. His main research theme is privacy in the digital world, and he is also interested in solving long-term scientific questions such as the existing tensions between massive data analysis and privacy, as well as ethical issues such as fairness, transparency, and algorithmic accountability raised by personalized systems. Sebastien, we're always so happy to hear you speak, and I'm sure this will be a good one. Please start. The floor is yours.
So thanks, Calvin, for the introduction. Just to say, I'm happy to take questions during the talks, if it's okay. I will let Calvin keep track of time in case we are going to go over.
Sure.
Time.
I'll monitor the gallery for hands as well and let you know.
Yeah, thank you. So one thing, so just one question. Do you see one slide or two slides?
Two.
Two. Okay, this might be the. Okay. It's a different screen that I'm using normally. So. Okay. Still two. Okay. I think this is a screen effect. Maybe I'm. I don't know. Just let me. Sorry. It's strange.
I think we can manage.
Are you sure?
Yep.
Okay, I can now. So basically, one thing I wanted to mention. So Calvin said that I work on the analysis of big data. Oh, so now it's different. Try something. Okay. So big data, just for everyone that might not be familiar. So sometime in computer science, we mentioned that big data is defined in terms of 5V. So it means that since 10 years ago, the amount of data that we have has increased quite a lot, but also the diversity of data. So basically, if some of you have a Fitbit accessory, it's able to track and monitor your physiological measure or your running speed, which we didn't have like 10 or 15 years ago. We also have a lot of connected device and connected camera in home IoT device. So all of this means that the data accessible about people has also increased. Velocity means basically that usually we don't take just one measure of your data, but data is being monitored on a regular basis. Once again, if you think about Fitbit, it's not just taking your running speed once during the day, but during basically a full period. So basically the promises of big data has been that because we have so much data and so diverse data, we can use it to solve tasks that were not possible before, or to develop some kind of knowledge about, for instance, the movement of people, the spread of disease that could not be possible if you have a small amount of data. And one thing that also has been really developing in the recent year is the fact that to be able to use this data, you need to have some learning algorithm that basically exploit the data. So I would say the conjunction of big data, what people call the deep learning revolution. So the fact that in also the last 10 or 15 years, we have been able to increase the success of machine learning on tasks that were considered difficult are really the keys that make the deep learning revolution. So for instance, now we are kind of used to have system where you basically give a picture and you have a very detailed textual description from the picture. But if you go back 15 years ago, it was considered difficult. So Sometimes even just predicting what kind of animal or what is in the picture was difficult, but now it's very easy. We also have systems which are able to play against a professional player on games such as Go. And this is really due to the, I would say, the conjunction of the big data, the algorithmic advance in machine learning, and also the increase in computational power. So basically, this success in machine learning in solving a lot of different tasks also means that now they are more and more integrated in service that really impact human life. So sometimes people call this high-stake decision-making system. So this is really a system where you have a machine learning model making a prediction about individual, and this prediction is put into action into a decision that impact people. So for instance, I've put here a list of what the AI Act consider as high-risk system. So if you use a machine learning model to decide, for instance, whether you give a student permit to a person, or if you use it to analyze automatically the curriculum vitae, or to decide if somebody get a loan, these really are contexts where people are affected by the prediction. So I'm mentioning this because these are really the contexts where we should pay attention of basically ethical issue, which I will mention after. One of them is, for instance, discrimination. So among the possible high-risk system, one particular one is prediction justice, where basically you try to make prediction about people. So for instance, the Compass tool was used to try to predict if you release somebody in advance, what will be the risk of recidivism. So the idea is that before, when it was done by a human, usually you have somebody which is an expert and is trying to interview the person which is currently in jail and trying to assess what are the risks for society if you let this person go out in advance, for instance, 2 years in advance before the end of the period. What are the risks that the person recidivates? And usually if the risk is high, the person stays in jail, and if it's low, the person is out. And one study has shown that basically Compass, which is one tool used in some county in Florida to predict this risk, is biased against Afro-Americans. So if you're Afro-American, you are twice as likely to be predicted at high risk compared to white Caucasian, even if the profiles are quite similar. So this has led to the development of initiative for the ethical development of AI. So sometimes people talk about responsible AI or trustworthy AI. So for instance, in Montreal, where I live, in 2018, we had a Montreal Declaration for Responsible Development of Artificial Intelligence, which basically says that if you develop AI systems that impact individual privacy is really an important aspect. So is autonomy, for instance, fairness, explainability, and other aspects. So if you look, I would say 7 years later, what was the impact of this declaration? I will say that it was good to raise awareness of people about this issue, but in terms of what companies are really doing on the ground, I think one of the main challenges is moving from this really ethical principle to really changing the way models are designed and used. So for instance, in Montreal, one of the issues is that a lot of companies have signed the declaration, but I don't think a lot of them have really changed their practice. So it's very easy to sign an ethical declaration, but it's not binding in the sense of the law. So there is no accountability, there will be no penalty if you don't respect the ethical principle, and even the ethical principle usually are very broadly defined. So it's to put them in practice is one of the difficult tasks. So more recently, I would say, as people have realized that ethical declaration might not be sufficient. So basically, one hope that people could have had like 7 years ago is that company will self-organize and try to have their own standard for responsible AI, but basically this has not changed a lot. So for instance, in Europe, you saw that now we have regulations that specifically target artificial intelligence. And the example I gave about high-risk system were taken from the AI Act. We also have updates on the privacy legislation, which also puts forward privacy, but also explanation and discrimination. And now, so this is the motivation to say that company will have to show now or in the near future that they are really taking care of ethical principles. So while before, when they had only signed a declaration, there was no auditor coming to knock on the door, things are going to change, at least for companies which are based in Europe or which have customers in Europe. And I wanted to mention, so for instance, the right to an explanation about a decision is already something that was in the European legislation for privacy. So basically, it says that if you have a decision which is taken about an individual, which has legal effect, so legal effect can be understood as having really an impact on person, you should give him an explanation about the decision reached, such that the person can basically maybe challenge or try to have another way to try to say that she's not happy with the decision. So one of the issues is that if you go to a bank, your loan is refused, but you don't have an explanation, it's very hard to try to say that something is wrong. Maybe there was an error in your profile or something, one of the rules does not make sense. But if you have an explanation, basically this is very important also for having a recourse mechanism. Another aspect is fairness. So still in the GDPR, it's mentioned that if you process information on a data subject, so basically on an individual, you have to take into account all the risk which can lead to discrimination. So in particular, the controller, so the company which use the information has to put in place statistical or mathematical procedure to ensure that the risk of discrimination are limited or minimized, especially on the basis of race, political opinion, religion, belief, trade union, health status, etc. So this is just to mention that even before the AI Act, we had already some provision in the privacy legislation in Europe about the other ethical issue like explanation and fairness. And basically, if you fall into the AI risk system, the AI Act asks you to do more things than if you are in a low risk. So for instance, maybe a company which is providing music recommendation does not fall into the high risk system because it recommends you music which does not impact your life. Also, people will discuss about it. So for instance, in Quebec, the recommendation of music that are made in Quebec are discoverability of such thing is very important. So I know people will not be happy if I say it's a low risk system, but at least for high risk system like immigration or the bank or social credits, you have to put in place a lot of requirements. So you have to establish a way to minimize the risk. You have to design system to achieve accuracy, robustness, and cybersecurity. You need to have also a human oversight to be sure that there is a human in the loop that can maybe reject predictions that don't make sense. And so this can lead to this risk of ethics washing, which is the topic of the talks of today. So ethics washing is something that was already studied for a long time in marketing. So I put it, one of the definitions that people use. So ethics washing, like greenwashing in some respects, is the practice of finding ethical consideration to improve how a person of organization is perceived. So greenwashing is a typical example that a lot of people will know about. So for instance, if you have an oil company which is saying we are doing a lot of initiatives to save the planet, this would be a form of greenwashing. So basically trying to pretend, or maybe you do stuff, but trying to say that you are doing things which save the environment while your core business is actually hurting the environment. And in machine learning, we define it as basically promoting the perception that a machine learning model or an algorithmic decision-making process. So I want to say that it doesn't need to be a deep neural network. It can be a very simple interpretable model or just a expert system. Respects some ethical value, which I will discuss example today of fairness, explainability, and privacy washing, while it might not be the case. So sometimes ethics washing can just be a choice of word during communication. So for instance, some company will basically just repeat the privacy regulation on their webpage, and they say, our company is respecting privacy because we respect And basically, it's just saying that they respect the law. So sometimes it's none more than some communication. But I will give some example today where you can also basically try to cheat on technical aspect to do some ethical washing. And so why will ethics washing, I think, be something that we will see more and more is because of this regulation that come where basically companies have to show that they take into account this ethical principle. There is a risk that they will try to game the auditor, try to game the system by trying to do some of this ethical washing. Is there any question so far? I don't see the chat, Khalid, so I don't know.
Nope.
No, okay, fine. So to give you one example of privacy washing, actually it's good that I have the two slides side by side. So in privacy, people have been working on a privacy model called differential privacy. So maybe you had some talk about this during the year by other PI from the CREATE grant. So differential privacy basically is a way in which the data of a particular person will be hidden by adding some noise to the computation. So for instance, one thing you can do when you train a machine learning model is to add noise on a stochastic gradient descent step to ensure that the contribution on one data point is very limited. So this has been invented by Cynthia Dwork and Kobe Nissim and others in 2006. It has been in the academic domain for like 10 years, but then in 2016, Apple tried to say, and I'm sorry it's in French, but I will translate that our functionality are improving, our data is now going to be private because we are using a new mechanism which is called differential privacy, by which your data will be mixed with the data of millions of other people. And doing that, we will be only able to extract generic patterns, but not information that can be really related to you directly. So for instance, this can be used to predict the most popular emoji doing this kind of technique. So as a researcher in privacy, this is really nice because a lot of things we do only stay as an academic paper or as a research prototype. Maybe one sad thing is that Apple didn't put differential privacy in everything. They put it in the prediction of emoji, which might not be the most critical machine learning tasks that they do, but still it's good. But one thing that Apple didn't want to say when they released that is the value of the privacy parameter epsilon. So epsilon is really what controls the level of noise and the privacy protection that you get. So they say we are doing differential privacy, but we won't give you the detail about the privacy parameter. And so if you do that to computer scientists, you are likely to have people that reverse engineering the approach. And basically some people did. And the value of epsilon that was used by Apple was actually 14, which is not a lot. So the noise that you had is very limited. So this, I put it as an example of privacy washing in the sense that the devil is in the details. So if I tell you I'm protecting your data with some anonymization of privacy mechanism, but there is a privacy parameter, which is almost always the case, which controls the trade-off between utility and privacy, and I don't give you the value of the privacy parameter, then basically, why should you trust that I put the value to be really protective if I am a company and my objective is to use the data? So this is an example of, I would say, of one of the first examples of privacy washing. So in terms of fairness, there was also some example of ethics washing. So before describing how it works, I just want to give you 3 slides on what is fairness in machine learning. I'm sure you might have some talk during the year already, but basically fairness in machine learning is a very active field. So if you would have been a PhD student 15 years ago, this would have been very good for you because the number of paper would have been very small, but now it's really there is thousands of papers published every year on how to make a machine learning fair. One of the difficulties is that there is several ways to define what it means to be fair. So one thing you can do, for instance, is to require the prediction of the model to be similar for similar profiles. So for instance, if you have a neural network which takes the profile of a person, So it extracts some feature from your curriculum vitae, and then he has to predict what would be the salary for you on a particular job. One thing that you would like to have is that if you have two curriculum vitae which are the same except from the gender or the race, you would hope that the system will produce the same prediction. So of course, we know that due to historical bias, the data is likely to be biased in the model also. But there is way to change the model to be sure that basically for similar profile, the prediction will be the same. So this is called individual fairness. So basically, it means during recruitment, candidates should be selected according to their competence, independently of gender or race. So this is one way to define fairness. Another way is to look at the statistic of groups. So you can, for instance, look at what are the proportion of females that were accepted in this particular position, what are the proportion of male, and you can try to modify also the learning algorithm or the machine learning model to ensure that the statistic of the group are balanced. And one of the challenges already that people have noted for a long time is that when you try to have several of this notion of fairness together, there is some situation where basically they are incompatible. So for instance, one way to achieve good fairness, if you think about the recruitment of male and female, and would be, for instance, to kind of have a positive discrimination where you increase the score of one group to be sure that the statistic of acceptance are matched. But if you do that, basically you are breaking individual fairness, because if you have two people with the same profile coming, but from different groups, like male and female, the fact that you do positive discrimination means that someone will have, like, even with the same profile, will have a higher chance to have a positive prediction. And there is many other examples, or even between group fairness notion where there is impossibility result. So as I mentioned, there is a lot of ways to enhance fairness. You can modify the data to try to remove some bias. You can change the learning optimization criterion from the algorithm to take care of accuracy and fairness. Or you can even post-process the model to change, for instance, the weight of the neural network or to do some filtering. One challenge is also there is no one-fits-all solution. So depending on the machine learning model, the type of data, so medical or finance data, and also the notion of fairness that you want, there is likely to be a research paper that say how to do that, but there is no solution which will give you the best trade-off in terms of fairness and utility in all the data and all the tasks. And one thing you need to be careful is sometimes you can be perfectly fair, but then you have no utility left. So for instance, if for every person that try to have a position, I just flip a coin, maybe I can be perfectly fair, so I don't look at the data. Everybody could have the same chance of being accepted, but then in terms of utility, there is nothing left. So to come back to ethics washing, there is a very good tutorial from Arvind Narayan and I will discuss all this fairness notion. So it's on YouTube, and basically one of the ways to do ethics washing is if you are a company and you didn't care about fairness, but there is a new regulation in Canada coming which says that in 2 years you are going to be audited for fairness. One thing you can do is just try the 21 fairness definition. And if by chance your model is fair according to one of these definitions, then basically you can just say to the auditor, which will come later, look, my model is fair according to this. And just this is like cherry picking the fairness notion that fits your needs. And this doesn't mean that you care about fairness and you choose a good fairness notion. You just pick one. So for each of these 21 fairness notions, there is a research paper with 10 or 100 of citations. So each of them has some kind of, I would say, some kind of scientific justification and citation from the community. And this kind of argument has already been seen even for the Compass dataset. So the Compass study was done by a collective called Machine Bias. So basically, which requests to have access to information about profile of people and the scores that the Compass tool were giving to them. And basically, they had a report which says that, as I mentioned before, if you're Afro-American, your chance to be predicted as high risk is twice as white Caucasian. But then later, the company which is doing this compass tool say, oh, we have seen this website from ProPublica, which published a story that our tool has some ethical issue. And we reject this claim because basically I'm not going to read everything, but they say that they didn't choose the right fairness notion to measure the discrimination risk of their model. And if you choose the right one, they will say that basically their model is fair. So I don't know which one is right or not, unless you have a whistleblower working in this company which can leak some internal documents. I think it's going to be very difficult to know if the company really takes care about fairness, but in a different way than the study. But you already see that there is the argument and the discussion about, okay, this model is unfair according to this fairness notion, and the company is saying, no, our model is fair if you look at this particular fairness notion. So two slides also on interpretability and explainability before going to other example of ethics washing. So as I mentioned, explainability is often seen as the third ethical requirement in addition of fairness and privacy. So I know there is some debate on definition, but just to give the definition that I'm using, interpretability for me is basically a characteristic of a model to be interpretable by design. So if you think about decision tree, for instance, it's very easy. So this is the decision tree learn on Compass, where basically you can have a path where each node is a test on a particular attribute, and you can go left or right. And when you decide to release or not somebody, or to say is at high risk, you can really give him the reason just by looking at the structure of the path. Other interpretable model are score risk, where basically you give some positive or negative points to people based on some characteristic, and you add everything, and at the end you compute the risk based on the score. And there is also other example such as rule list. So these are really model where from the start you decided to learn a model where it's very easy to explain to humans why the prediction was made. Another big part of the research which is often called XAI, so explainable AI, is what I call post-hoc explanation, where you have already trained your black box model, so for instance, your neural networks. And now you are trying to build explanation that explain what is the model doing or about particular prediction of the model. So for instance, one thing that people do, which is called global explanation, is to try to learn an interpretable model which is quite faithful to the black box. So the idea is you hope that in terms of agreement of prediction, you are able to build a model which is, I don't know, 90 or 95% faithful to the black box. And then you use the interpretable model to explain the black box. So if the fidelity will be 100%, then basically it would mean that there is no point in having a black box model. You could just use your interpretable model. But so often, because the interpretable model are simpler, the capacity is lower, and you will have some discrepancy in terms of fidelity. Another way people explain black box model is by trying to do some feature importance. So if you have heard already about LIME, what LIME is doing is trying to say, okay, this network predicted on a profile of a patient that he has a flu based on different symptoms which were in the input profile. And actually, LIME says that the fact that the patient was sneezing and had some headache is really important. So it's really an important feature to make this prediction. But the fact that he has not fatigue was not really important in this decision. So this is a way to kind of, for a human, so for instance, for a doctor to say, okay, maybe the prediction makes sense or no sense because the model is trying to say, okay, these particular symptoms are the ones that are important. Okay, any questions so far on explainability, interpretability, or fairness?
No notes in the chat for you, Sebastien.
Okay. So one thing that people know for a long time is that explanation can be easily manipulated. So there is a lot of paper about that, but this one I really like because it's very easy to convince people. So this particular type of explanation is called saliency map. So basically, the idea is that if you have a classification model that takes a picture and make a prediction that you have a dog, for instance, or something else in a picture, one thing that you could ask is which pixel were really important to say that this is a dog. So normally you would expect that the model has been predicting this is a dog because he has recognized that the ear, the eyes, and the nose are very important. But then you can do some kind of adversarial example manipulation of the input profile where, I mean, me as a human, I don't see any difference between the two. But when you apply the explanation technique, basically, you can really have any pixel which are put on or off. So it's really an adversarial example where the human don't see the difference, but the machine can make any explanation that you want based on this particular attack. So this is really an example where you see that if you have an adversarial situation where a company or somebody is trying to cheat on the explanation, it's possible to basically make the explanation say anything you want on this particular case. So in our case, we try to work with other people. So Ulrich, which is a professor in ETS, was a postdoc. Hiromi, which is working in RIKEN in Japan. Interns that we had, Olivier, Satoshi Hara, which is also a professor in Japan, and Alatin from the University of Montreal, on what we call fair washing through rationalization. So I'm going to give more detail on that. But the idea is that if you use a post-hoc explanation to explain a black box model like a neural network, you can try to cheat on the explanation to make it appear like if the model is fair based on the prediction of the explanation. Well, actually, it is not fair if you look at the prediction of the original black box. We call it rationalization in the sense that as humans, sometimes we do some action without having some reason. So maybe you do a good action or bad action, you didn't think about it. But then later you try to come up with an explanation for yourself that explains this particular prediction or decision. And this is what we call as a rationalization. So the fact of coming with an interpretable model which explains the black box, which makes it appear like if the original black box is fair while it was not the case. So if you look, the idea would be if you have a scoring system used in Europe, now the AI Act is going to ask to provide explanation. So before, if you look directly at the prediction API, you could see that a group was more favor in terms of predictive prediction than other. But then if you only access through the system to the explanation API, basically if you measure the fairness on the explanation API, you will see that the model appears to be fair according to a particular metric. For the first work that you use, we were using rule list. So basically a rule list is like a decision tree, but in which you do if then rules. And then, so this is an example of rule list for the adult data set. So you look if the occupation is white collar. If this is the case, you do predict a particular label. If not, you go to the next rule list. And then at the end, you do a default prediction if none of none of the rules above were successful. So to try to measure the possibility of fair washing, we look at a demographic parity, which is a fairness notion. So basically, demographic parity look at the difference of the positive prediction for two groups. So basically, if P1 of S would be the probability that a male would be higher at a particular job, and P1 of S tilde would be the probability that a female would be higher, you can try to look at the unfairness as basically the absolute difference between the two. So if the unfairness is 0, it means that the two groups have the same probability. If it's higher than 0, the higher, the more unfair the system is. And the fidelity is basically measuring the agreement between the surrogate model, which is the interpretable model that you build to explain the original black box model. So to do this fair washing, we exploit some algorithm which produce rule lists. So Corel is an algorithm which uses a branch and bound technique to try to find really a small rule list, which is trying to optimize the size of the rule list, but also the error. And another tool which was developed by one of our co-authors, which is called model enumeration. So the idea in model enumeration is that in a lot of cases, you don't want just one model, but maybe you want a lot of model which have the same accuracy. So one thing you can do is do model enumeration and produce not only one rule list, which is faithful to the black box, but a lot of different ones which all have a high fidelity. And we call our algorithm laundry ML. So Ibrahim was asking, what are we washing today? So we are washing the fairness by doing manipulating explanation. So basically, the idea is that we modified the objective function of correls to try to also produce an explanation which is small in terms of size of rule list, faithful to the black box, but also where the unfairness is really decreased compared to the black box. So in our first paper, we tested on two data sets, which are very common in the fairness literature. One is adult data set, where basically your task is to predict the salary of the person. And the gender is usually considered as a kind of discriminatory attribute. So the salary of men and female are very different. We also use the data sets that were used by ProPublica on Compass, where here the race is obviously a characteristic that can lead to discrimination. We use as black box random forest. So if you look in the original data set, the unfairness is 0.13 for adults and 0.17 for ProPublica. So I remind you, 0 will be like a fair system, and the more it's higher, the less unfair the model is. And so basically, the thing that we can do to fair wash is basically this Pareto front. So I don't know if it's big enough for everyone, but here you have the unfairness of the surrogate model that you produce. And here you have the fidelity to the black box. So basically, if you have a law which come and say, okay, it's okay to use post-hoc explanation where you build an interpretable model to explain a black box model as long as the fidelity is at least 90%. One thing you can do is look at the point which is just above this limit and pick it as a model that you use for fair washing. So here you see that basically you can have a model which is 90% faithful and which has an unfairness which is half of the original black box. So if your requirement in terms of fidelity is even lower, you can pick one of these points here. If it's higher, you can go in this part of the Pareto front. So basically, this means that you can easily, with this technique, try to build models which are really less unfair than the black box, which still have a high fidelity, 90 or 95%. So on ProPublica, you might say that here the fidelity is very low, but one thing I want to mention is even the black box are does not work really on recidivism, and this is really because if you imagine you have a human and you are trying to predict the risk of this person recidivate, this is really a task which is difficult for machine learning. So in particular, there is a lot of things that could happen when you go out in society. Maybe you have a family that will help you. Maybe you have a reinsertion program. So it's very difficult just to look at the profile of a person that went to jail and say, okay, what are the risks that it will recidivate? So even black box usually have like 55 or 67% of accuracy, and this is the fidelity. So it's mean in terms of interpretable model, we can have one which is 3 times out of 4 is in agreement with the prediction of the black box model. So one thing we also did after is on the left, you have the feature importance of the black box in making prediction, and on the right, you have of the fair wash model. And one thing we wanted to see also is that on the original black box, the gender and the race, for instance, are very important for the prediction. So if you look at feature importance, the technique will say it has a lot of weight in the prediction. But if you look in the fair wash model, basically it's really go down. So it means that it's also a way to do fair wash the model if the auditor is using feature importance to try to detect fairness issue. So one thing that you might ask is why is fair matching possible? And I want to mention this. It's due to a phenomenon which is called predictive multiplicity. So usually some people, when they start a machine learning class for the first time, you get the impression that, I don't know, if you take the adult data set and you have a model which is 85% accurate, people think that there is only one model that has this accuracy, but actually predictive multiplicity is a phenomenon that Breiman observed, and which says that there is a lot of models which can have the same accuracy on a particular task, not just one, and it can be a huge set. So basically, we are exploiting that for fair washing in the sense that when you are to produce an interpretable model which extends a black box, there is not just one model which has a high fidelity. There is a lot of them, and sometimes it's called the Rashomon set. So it refers to a movie from Kurosawa, which is called Rashomon, where basically you have several people seeing the same crime, but from different witness. Each of them has a different opinion of what happened. And so the Rashomon set also means that there is a lot of interpretable models that can explain the black box. And we are exploiting the search in this space to try to find one where the fairness is much better than on the black box. So basically, later we did some follow-up work where we try to see. So one hope that you could have is that maybe fair washing is possible with random forest, but not with neural network or the other way around. But actually, we tested into boosting model, deep neural network, random forest, and basically all type of model can be fair wash. We tested on different data sets with different fairness notion. And actually fair washing is something that could happen. So, I mean, the level where you can do it might change depending on the characteristic of the data. But this is something that is possible in all type of black box model, all type of fairness metrics, and all kind of data at least that we tried. So for all these experiments, you always have this Pareto front where you have like the fidelity to the black box and the unfairness level, where 0 is like perfectly fair on the interpretable model, and here are the bars that you get on the original black box model. So on subsequent work with other people, so in particular with a student from Nicolas Paperno, we work on trying to see whether this could be detected, and basically you could try to detect this by doing statistics between different subgroups, but still it's kind of very difficult. So yes, we think that it's possible to detect to some level, but there is still a way to, I would say, for the company to cheat. So we could have some way to try to test through the prediction API, but still it's difficult. And why is that? It's basically usually ethical washing, and this is true also in the marketing sense, so in the classical, where there is no machine learning and no big data. Usually, companies do ethics washing when there is some part of the law which is not well defined or not specific. And so one of the issues that often people have is that proving intentionality, so proving that the company really wanted to cheat, is difficult. So if you go back to the example of cherry picking the fairness notion, I think unless you have somebody inside the company, it's very different to if the company say, okay, our model is fair according to this metric. You don't know if the metric was just cherry pick or if there was really the company trying to do its best by really choosing a metric carefully. So as long as there is no standard which is really specific about which metric to use on a particular context, then I think there will be some way for company to kind of be very flexible in terms of the choice of the metric or the type of explanation, and just to do ethics washing. So one thing that I mean, the way I see to go forward would be the following. One thing you could do is take any domain. So take the finance domain or the medical domain. One thing that you could have is, so I will take the example of Quebec. So in Quebec, in the finance domain, we have a regulator/auditor entity called Agence des marchés financiers, which is responsible to regulate the banks, for instance, maybe this entity, which is already in place, could say, okay, I'm going to organize a public consultation where all the stakeholders, so the company, but also us, academic experts, representatives from the civil society, will work together on defining what fairness notion makes sense in this particular context, what type of explanation makes sense also, for instance, for loan prediction. And then if you are able to have a kind of more specific standard on this particular setting, one thing you could do after is to use privacy to try to be sure that the model which is produced and used is really the one that has been done using this specific standard that you have. So one thing that you can do with cryptography is, for instance, prove. So one thing that the company could do is commit their training data, so in the cryptographic sense, so give to the auditor a version of the data encrypted, and then prove that the model that they have at the end has been computed according to a particular fairness-aware algorithm without having to reveal their data. So one big issue that people have currently with the audit of AI system is that a lot of time the company will say to the auditor, I cannot show you the data of my client because either of privacy legislation or because it's a proprietary asset of the company. So using cryptography, you could prove that the model has been produced to be fair without having to show the particular training data. So we use this idea, for instance, in the case of fair decision tree, still with people from the group of Nicolas Paperno. And then lately I'm seeing, so this was in 2023, and then last year and this year, I'm seeing more and more papers trying to do the same approach. So basically combining cryptography to ensure privacy, but also proving some property about the model. So there is one work which is doing proof of individual fairness. In our case, it was for group fairness notion. So basically it will use zero knowledge proof and other tool in cryptography. So I don't know if you had talked during the year about this, but basically this is a way to prove information about your data without having to reveal your data. But this could be used also to prove information about the model which is learned on the data. And then recently people have tried to use this approach by doing what they call end-to-end. So basically from the pre-processing pipeline to really the inference time on fairness using zero knowledge proof. So one thing also I wanted to mention is I see some also some synergy between some some legal duty and also this kind of approach. So for instance, in USA, I saw a talk last year at the FAC conference which basically says that, okay, if you have a company and you have a model, so for instance, go back to the loan prediction at the bank, it's sometimes okay to discriminate as long as you can prove that you look for all the particular alternative model and that you didn't find one which is really less discriminating and which still maintain a high prediction power. So this was called in this paper the legal duty to search for less discriminatory algorithm. But basically, there will be a way, for instance, to try to search in the Rashomon set of model and maybe to force company to really show that the models that they choose are the one which is in terms of accuracy as a high accuracy, but still is less unfair at the beginning. So one thing you can do is try to force company to do this search without revealing their data using cryptography. So I don't know if I'm clear, but I can, during the question, I can come back to that. So this will be a kind of way where company will have to really prove that they just didn't create one model without thinking about fairness, but they really explore the Rashomon set that I was mentioning. And then I want to finish my talk by giving you example of privacy washing. So I give you one example of privacy washing at the beginning, but then I went to ethics washing in terms of fair washing, so fairness and explainability. And now I think privacy washing is something that we'll see more and more. And I want to give you a few recent examples of such a case. So for instance, one example of privacy washing that you might know is Zoom. So we are on Zoom right now, and maybe if you remember during the pandemics, Zoom at some point were saying we are doing end-to-end encryption, so us as a company, we cannot see what you say or we cannot see the video, which was actually false. So the FTC in US basically had an investigation, and this is a settlement with the FTC where basically they say that Zoom misleading claims that there was a false sense of security in the sense that all the information was not end-to-end encrypted. Basically, the company had the key to decrypt everything. So this is also an example of privacy washing. Another example that I see of privacy washing is so some company doing what they call privacy preserving face biometrics. So basically, the idea is that some company will say, okay, we are gonna do facial recognition, but instead of having my face like now that you see me on the camera, you are gonna put some blurring on you or some mask. And then basically we will show that we can still predict maybe your age or if you're happy or not happy, but not identify you. And one of the issues with a lot of this paper is basically the way that they evaluate the re-identification risk. So one thing that they do is you train a machine learning model to have face of people. So one class will be Sebastien Gambs. There is 10 pictures of me. The model is trained to predict Sebastien Gambs when it's my face, and then you have a new face coming. And then what people do is they modify the image and they say, okay, look, this model is not able to predict the identity of the person anymore when we modified the picture. So maybe I can try to see if everybody is awake. So do you see why, in terms of robust evaluation, this is an issue? Like the fact that you train a model on data which is not modified, and then you evaluate it on data which has been modified. Do you think it's a good way to go to evaluate the robustness of this model?
I saw Oben in deep thought.
Yeah, I was trying to come up with an answer, but I guess it's not a good way of doing it. But
Yes, the idea is that what you would like to do is rather you go for a different learning task where so you train a new model where you have the face of people modified. So the idea is you distort the face of people according to the particular privacy preserving techniques. And then you train this new model, and then you give to this model image of the person that they have not seen during training, but still modified with the same technique. And you see if the model can recognize them. So this is more robust in the sense that for the first one is you had a model trained on data which is not noisy, and then you evaluate it on noisy data and the prediction are bad. This is kind of what we would expect, but this does not show that it's not possible to build another model trained on noisy data which can still predict the identity of people. So this means that really the evaluation should be done by training a particular attack model which really based on the modified data, the anonymized data, not the original data. And this is, I mean, some people have tried to really say that people should be careful because if you claim that the technique is private but the evaluation is not robust, so basically it's a false claim of privacy in the sense that a real adversary could easily re-identify people which modified their image using this technique. Another example of privacy washing is with WorldCon. So maybe I can see if other people are awake. So who know what WorldCon is? is trying to do as a company.
I'm not familiar with it personally.
So yeah, nobody. So okay, I can give you. So Worldcoin is a company co-founded by Sam Altman, so one of the founder of OpenAI, and basically the idea is that to give a global digital identity to everyone, which is based on iris data, so biometric data. And one thing that they try to do is they try to, so they are using cryptographic tools like secret sharing and zero knowledge proof. And there are, so here on the left, you see like a table of content of their white paper, which explain what they do. And you see that there is anonymity, so security, secure math, what we do, anonymity, move freely online, choice and control. So they do a lot of cryptography stuff. But basically, they are trying to say, because we do all this privacy enhancing technology, it's not personal data anymore, so we don't need to obey to the privacy regulation. And actually, this was not a lot of data protection authority were doing an investigation, and very recently, basically the Bavarian Data Protection Authority, but a lot of European, I think, are going in the same direction, says that it's not because you encrypt or put your iris data, which is really biometric and then personal data, using some privacy enhancing technology that they are not personal data anymore. So basically, the iris code, the authority says that the company should erase all the data that they have collected so far, because their argument that because they use privacy, no, it's legitimate to use or collect this data is not true anymore. So I call it an example of privacy washing. So basically, where you put some privacy enhancing technology to try to say that you can collect data that people would not agree or seem legitimate in a different situation. And then just to finish with last example, one that people have seen talk more and more is federated learning. So federated learning, the idea is that you have data distributing among several entities, and you have a kind of central server which is trusted, which is coordinating the learning of a global model. So people don't have to send their data to the trusted server, but they have to send update of their model. So this is privacy preserving technology. It's enabled to learn a global model without to have your data centralized. I think it makes a lot of sense in like the usual scenario about hospital, where you have hospitals that cannot share the data. But actually, more and more people are saying that this is used as a way to enable new flow of information from individual to company that would not have been accepted by user differently. So basically, this is an example where you put privacy enhancing technology to kind of justify the collection of new data. Maybe some situation makes sense like hospital, but maybe in other where you have like millions of phone of users, this is also endanger the privacy, because now you have access to a lot of information about them. And I look in the legal domain, and people sometimes are referring this to what they call privacy pretext. So basically, just reading one sentence, platform like Amazon, Facebook, and Google, wall of information from company in the name of privacy. So one risk also is that when you use this kind of privacy enhancing technology, I think it's also a way to escape the auditor coming. So basically, when the auditor is coming and gonna ask you, can you prove that your model is fair? Can you prove that it has been done ethically? You can also try to put before some privacy technology and say, oh, sorry, I don't have access to my data in clear anymore. Or maybe the way the technology works make it very difficult to audit, but don't worry, it's fine. We are using privacy enhancing technology, so you don't need to come after us. So this is one risk also, using privacy enhancing technology to stop from auditing other techniques. And basically that's it for me.
Fantastic. Thank you so much. Sebastien.